Hello wonderful person, this is Anton, and in today's video we're going to be using Universe Sandbox Square to talk about the mission that actually turned 40 years old pretty much today when I'm filming this video, and this is the mission known as Voyager 2. We're going to talk why this mission is important, why it's actually kind of cool, and go through some of the important findings of this mission that it has lasted pretty much longer than I've been in existence. Anyway, welcome to What the Math. So there's quite a lot of simulations in Universe Sandbox that touch on different Voyager missions, but this here you'll actually get to see how back in 1989 Voyager 2 actually passed by Jupiter and took some incredible photos of Jupiter, and at the same time also got to accelerate to higher speeds using what's known as a slingshot maneuver. Now we're actually going to be talking about this mission because on August 20th of 2017 it turned 40 years old. 40 years old. That's pretty old when you think about it. I think most viewers I have are, including myself of course, are much younger than that. In other words, this machine that you see right here, this incredible device, has been in space longer than we've been in existence and longer than we've even been in planning. Our parents haven't even planned this by the time it was already launched in space and possibly even visited something. Now there's two Voyagers. There's Voyager 1 and there's Voyager 2, and I'm going to show you both when I enable everything. And they actually got launched around pretty much the same time, but Voyager 2 got launched a little bit earlier. Voyager 1 is already here. And the interesting thing about them is that they were launched for a very interesting reason. Back in the 60s, mid-60s, a scientist studying various planetary interactions discovered completely by accident that in late 70s, and he didn't really know the date just yet, but in the late 70s, there would be a planetary alignment between Jupiter, Saturn, Uranus, and Neptune in such a way where you can actually go from one of these to another and visit all four on a single mission. This is basically known as a grand tour, or I guess like a miniature grand tour, because you only visit 4 planets. And once these scientists realized that this was actually possible, what they've decided to do is they've decided to launch several missions, but then had to downscale and only launch 2 of them, and they were later renamed as Voyager 1 and Voyager 2, and their missions were pretty simple. Visit Jupiter and Saturn as a priority. That's why both of them got to visit both of these. And for Voyager 2, the secondary mission was to visit Uranus and Neptune, but it was launched toward Jupiter and Saturn in case Voyager 1 failed for some reason, because these 2 were the priority. And so basically both of these probes got to visit Jupiter and Saturn, take some photos, do some studies. But today we'll focus on Voyager 2 because it's its birthday, and because basically this is the mission that visited all 4 planets, all 4 giants, and at the same time it's the only mission that ever visited Uranus and Neptune, because until that time we only knew about these 2 planets from observing them with large telescopes, but nothing really massive enough to see the details. Now let's start with the initial trajectory here, and you can kind of see that both of these probes basically left Earth, and Voyager 1 was actually moving a little bit faster, and even today it's moving faster and faster, and will actually get farther and farther apart, because that was the whole purpose of this mission, for Voyager 1 to go a little bit faster and for Voyager 2 to be the secondary backup probe. But then Voyager 2 ended up being a lot cooler because it got to visit all of the planets, or all 4 gas giants, and 2 gas giants and 2 ice giants. I'm making a few mistakes here, my apologies. Anyway, so in 1979, this is 2 years after the launch, it started to approach Jupiter, and this is when things started to get really cool. Now the primary mission for this probe would actually end in 1989, but then scientists realized that the probe that they made was a lot cooler than it seemed, and so the mission continues even today. But we're going to talk about this in a few seconds, because we're just going to start the mission first. And so it approached Jupiter, and as it approached Jupiter, it actually started to discover some really cool things. So its closest approach happened on July 9th of 1979, and it came within about 570,000 kilometers from Jupiter. And at this point, it basically got the so-called gravity assist, which by then was a completely newly discovered thing. People were actually pretty excited about it. They didn't really know if it's going to work, but it did. And the gravity assist here increased the speed of Voyager and would increase it every single time it passed a planet. And so as it passed close to Jupiter, it got to observe the cloud tops, it got to actually take some really cool pictures. It actually even discovered a few new rings around Jupiter that Voyager 1 didn't. And most importantly, it actually got to observe and take photos of the volcanic activity on Io. This was the first time ever we've seen an outside object with volcanic activity, and this was pretty exciting because people didn't think these places existed in our solar system. So that was cool. Also, Great Red Spot, which is right somewhere here. Somewhere, there it is. The Great Red Spot was actually revealed to be a complex storm moving in counterclockwise direction. Until then, we didn't really know what it was. And another unusual discovery was in regards to Europa, which is right here. And what was very, very unusual for the scientists to observe are these really interesting cracks everywhere. Until then, they actually thought these were probably caused by some kind of a tectonic process, like movement of tectonic plates. But we'll actually talk about this in some of the future videos, because at this point the scientists were puzzled by this. They actually felt like this was something just painted over Europa. It didn't seem real. They didn't actually believe these were real. And they couldn't really explain them until relatively recently, actually. But if you want to learn more, you can either watch the previous Europa video I made, or just wait for a new video where I'll explain this in a little bit more detail. And on top of that, some of these satellites, actually these 3 satellites, were discovered during this trip as well. So Amalthea, not Amalthea, Adrastea, there it is. Metis and Thebe were all discovered during Voyager 2 passage close to Jupiter. Now, then basically the probe moved on to Saturn. So a few more years will pass, and in 1981, the probe is going to arrive to Saturn. And here, no major discoveries were made by this specific probe, because it wasn't really the focus. Here, the idea was to maybe see something new that we haven't seen before, but most importantly, to use another beautiful acceleration right now, right there, another slingshot maneuver to get some more speed so that we can now move to the direction of our destination, Uranus. This is the first time Uranus is going to be visited, and the scientists got really, really excited about this, because here, this is when lots of discoveries are going to occur. And so this is 1986, January 23rd of 1986, and this is when we begin tons and tons of discoveries about this unusual planet. First of all, we realize that orbits on its side, and all of the moons also orbit on the sort of side. Basically, they're inclined to the main plane of orbit in our solar system. We've discovered quite a lot of moons. As a matter of fact, a very, very large variety of moons, including Cordelia, Ophelia, Bianca, and so on. And we also got to study the unique atmosphere of Uranus in a lot more detail. And we examined the Uranian ring system, which we knew existed, but we didn't really get to study it close by. So in 1986, we actually got to see a lot of detail about Uranus using Voyager 2 tools. But some of the more unusual discoveries were in regards to its very, very unusual magnetic field on Uranus, if you actually enable it, or also known as the magnetosphere, is also shaped very weirdly. Now here it won't actually seem that way, because it does look like a normal magnetic field, but in reality it's actually tilted and shifted in a way because of its spin. And so because Uranus spins on its side, it actually creates a very unusual drop-like shape that doesn't exist anywhere else in our solar system. And we also discovered the mysterious Miranda. Now this moon is crazy. It doesn't look like that actually in real life. As a matter of fact, it looks more like this. Miranda is, well, one word for it is ugly, but the other word is very unique and very unusual. And so here we are passing by Miranda right now. It seems to have experienced quite a lot of maybe collisions or some kind of really unusual physical interactions with other objects, because it looks like nothing else in the solar system, and we don't really know how to explain it, still, even today. And once we've discovered all of this, we go to our final destination, also known as the end of the mission, Neptune. Now this is 1989, this is basically 3 years after Uranus, and here we are approaching the technical end of the mission. Voyager spacecraft were actually equipped with quite a lot of redundant mechanisms and engines and essentially all kinds of devices that, if something fails, the other mechanisms will be able to take over and complete the mission. Because of this, Neptune wasn't really the end. Because of all of the extra devices, these Voyager 1 and Voyager 2 probes are actually still able to function even today. But anyway, so what the scientists decided to do when they were approaching Neptune is to actually change the trajectory so that we can move close to Triton. Now, in this mission, I don't think we'll be passing by there, but this is when they decided to expand the entire amount of leftover fuel to change the trajectory to basically have a flyby near Triton, and then it would kind of bounce off and move to the southern area of the plane of orbits, and then kind of move into the direction for the rest of its time in our solar system. So by expanding the fuel and by basically changing trajectory, the trajectory of Voyager 2 spacecraft was changed by about 30 degrees, which is quite a lot actually. And so here we are going to be flying by Neptune, getting our last sort of boost, and hopefully not collide with it. I don't think we'll be colliding with it. And essentially this is when we took some photos of Neptune, got to study its atmosphere as well, its magnetosphere, and discovered some things about Triton, realized it was orbiting in the opposite direction, and tried to explain it by basically comparing it to objects like Pluto. And one of the things we actually detected on Neptune, which doesn't actually exist in Universe Sandbox, is the so-called Great Dark Spot of Neptune. It's a spot or a storm similar to the one on Jupiter, but this one actually disappears a lot more often. As a matter of fact, it's very seasonal and it does disappear pretty much every month or so it doesn't last very long. And we don't really know how it's formed and what it does exactly, but we know it's there. We also were at this point transmitting all of the data at a very, very slow speed of about 160 kilobytes per second. Now, if you ever had dial-up when you were younger, you may remember how slow that is. At some point, because even though the antenna here is very large, and you can kind of see it, it's right there. Even though the antenna is very large, we're going to reach a point in space where the transmission is going to be 160 bytes per second, or I guess in this case it's 160 B per second. And that's super, super slow, and it's actually transmitting at this speed right now, and at some point it's going to slow down even more. It's because right now, where we are right now in space, we are right there. We're at a distance of about 106 astronomical units away from the sun, basically something like 3.5 times the distance of Neptune from the sun. And at this distance, it's pretty far. It's actually so far that we're barely even detecting Voyager 2 spacecraft now. Voyager 1 is even farther away because it's moving a little bit fast, and you can see both of them on this map actually. So there's Voyager 2 and there's Voyager 1, and look how far away they are from each other. And they'll be moving in this trajectory, this escape trajectory, for basically the rest of their existence in the universe until they collide with something or something eats them up. In about 80,000 years or so, Voyager 2 will finally reach the nearest star, but it's actually going to be still pretty far away from those stars, because I think the nearest approach will be at like 1.7 light years, which is still very, very far. But technically, Voyager 1 has actually unofficially left the so-called magnetosphere or heliosheath of our sun, but Voyager 2 is still inside. So our solar heliosheath, the magnetosphere of our sun, is so large that it expands all the way here. And Voyager 1 has actually shut down its devices a while ago, but Voyager 2 still has the so-called plasma measurement device that we're going to be using in 2019 to try to once again use it for scientific purposes and measure the difference between the inside of the helio sheath and the outside of it. Basically, we're going to be measuring the difference in plasma pressure, which is going to be pretty exciting for some scientists because we'll get to find out what the interstellar space consists of, which we still haven't really done up to now. And so this approach, or I guess this exit from the so-called heliopause will happen sometime in 2019, and this is when the Voyager 2 will probably be in the news again, because we'll be studying this in a lot more detail and hoping that it still works, because it did have a bit of a bug a few years ago when, for some reason, and you can't even see it anymore actually, for some reason the one of the devices on Voyager 2 started to receive, or not receive, but send things with an error. It actually had one of the bits flip, unfortunately. And so what some people thought, there was instantly a conspiracy theory, they thought it was aliens trying to communicate with us. Turns out it was just a simple mechanical error that was then reset and everything was fine right afterwards. Why did that happen? Well, this thing is like 40 years old. What do you expect, you know? Anyway. This mission is overall still really cool, and is probably one of the coolest missions we've ever launched. Now, the fact that this thing can still communicate with us, and the fact that we're still able to detect signals from both Voyager craft, and also the fact that we can still even use it for science after 40 years, definitely makes it one of the best missions ever. It still transmits at the 13 centimeter wavelength, S-band wavelength, and it uses a very cool, very unusual technique for measuring its location in space using Canopus star. And it's actually something that kind of similar to, like in the old days, captains of ships used to use Polaris for navigation. All of the spacecraft, or most spacecraft today, use Canopus, and I'll talk more about this in one of the future videos. Now, I accelerated time here, making it 1 year per second, and you can kind of see these two probes slowly escaping our solar system, and they'll be doing this for many thousands of years because our solar system is much larger than we initially thought back when we launched Voyager spacecraft. But unfortunately, by the year 2025, Voyager 2 will actually have expanded its fuel cells. It uses very interesting plutonium-based fuel cells that usually last for about 50 years. But this one might last longer because they did decrease energy consumption. And so in 2025, it will finally not be able to power anything anymore. So these two probes, specifically Voyager 2 probe, will become inactive and just drift in space, bringing with it an unusual gold-plated audio-visual disc. It's basically a disc that was placed on both of these crafts with like stuff like music, some pictures from Earth, unusual greetings from UN Secretary and the President of US back then, and also things like children crying, waves breaking on the shore, different types of music by Mozart and a few other artists. I'm not sure how aliens might receive this and how they will react to this, especially the kids crying. They might think that we're asking for help, even though this was technically just an unusual greeting from Earth. But that's the probe in a nutshell. That's its mission after 40 years and the future until 2025. We're still going to be sending more and more probes, but looks like in the past 40 years, this was the one that basically inspired many generations and is still the one probe that is kind of surprisingly unusually active and definitely will create some more buzz in 2019. Now, just to go back and show it to you again, this right here that basically shows you the beginning of this mission when it flew past Jupiter, took some amazing photos on Io, discovered volcanism, took the pictures of the spot on Jupiter, and basically inspired future generations of astronomers and space scientists. But most importantly, this showed us how resilient human beings are and how creative we are when it comes to exploring our solar system. How we can actually combine forces and create this amazing device that will function for generations. And honestly, we need something more like this in the future, because in the past few years, I cannot name a single object that achieved just as much as Voyager 2. Anyway, hopefully you learned something about Voyager in this video, and hopefully now you know a little bit more about it. And if you did, don't forget to subscribe, share this video with someone who enjoys watching space videos, and come back tomorrow to learn something else. I'll see you guys tomorrow. space out, and as always, bye-bye. And in the alternative universe, where Voyager was passing by Jupiter, something happened to Jupiter, and it exploded. Because why not, right? It's a video game. We can do anything.